This project is sponsored by PCBWay. From July 1st to July 31st, 2026, PCBWay is organizing 12th anniversary campaign. Grab your discount and unlock more rewards in the form of exclusive coupons, PCB orders for just $5, Trunky electronic design services, up to 50% off for 3D printing and CNC machining, and special sales in PCBWay store. Join the fun with interactive games and receive your exclusive engineer color personality. Click the box to participate in the lucky draw, show your colorful projects and vote for the most popular badge. Order now and get big discounts. Hello, recently I had an unpleasant experience in my home, specifically my ground floor was flooded as a result of a burst water pipe. At that moment I was absent. So I decided to develop a warning system for such phenomena that would also take some action in order to prevent greater damage from occurring. For this purpose I purchased the Gravity Photoelectric High Accuracy Liquid Level Sensor for Arduino from DF Robot, which has good sensitivity and no need for mechanical parts, and is also corrosion resistant and can handle high temperature and high pressure. The way this photoelectric sensor will work as follows. When the detected level is in air, due to the reflex of the prism, most of light will enter receiver LED optical level sensor with output high voltage. And when the detected level is in water, due to refraction of the liquid, just less of light enter receiver LED and optical level sensor with output low voltage. The level of the output voltage from this sensor is the same as the power supply, and since it can be powered by 3.3 volts, I can connect it directly to the ESP32 input. It can be mechanically installed in any direction, and specifically for this demonstration I made a small stand on which the sensor is mounted. The tip of sensor should be just above the floor to detect even the slightest accumulation of water. As I mentioned earlier, I plan to use an ESP32 microcontroller for several reasons. It is cheap, has low power consumption, supports Wi-Fi and Bluetooth, and has other advantages over most Arduino boards. A basic requirement when planning my project was the option to receive information about the current situation no matter where I am via the mobile network on my smartphone. There are several services for this purpose, and I choose the Telegram platform because it allows a creation of bots that can perform automated tasks and completely free of charge. So if you haven't had one before, you need to open a Telegram account and create a bot. This procedure I described in detail in several places, so I don't plan to go into detail here. However, in the project description I give you instructions on how to create a Telegram bot yourself. It is important that when creating a Telegram bot we get two distinct unique strings of characters. One is the HTTP AP token and other is the ID. We need this information later when creating ESP32 code. Having already mentioned the code, I should say that it is designed in a way that can be easily changed several parameters, including the warning test that we receive on the smartphone. At first, the credential from the local Wi-Fi network should be entered, and then the received Telegram token and ID. Next is the definition of the pins that we use on the ESP32, and then the corresponding messages that we receive on the smartphone depending on the state. As I mentioned earlier, these messages can be changed according to our own wishes without any other changes to the code. It is also very important to mention that with this Telegram bot we have the possibility of two-way communication, which means that in addition to receiving messages we can also give commands via the smartphone to perform some task remotely. To install the code without errors, we need to select ESP32 dev module board in the board manager and install the provided libraries Universal Telegram Bot 130 and Arduino JSON 6.21.6. The following is a demonstration of the functionality of the system in real conditions. For this purpose, I will use a container in which I will simulate a flood and a miniature water pump to drain the water. First, I will bring the power to the ESP32 via the USB port. Now ESP32 is active. After a few seconds we receive a message on the smartphone that the system is active. Now let's check the status in the room where the system is installed. For this purpose we write the command \status. Soon we receive a system report that describes the state in detail. In this case, a dry room, the valve is open and the blue and red LEDs are off. This message arrives at the smartphone via the mobile network, which means we will receive them anywhere in the world. As I mentioned before, the communication system is two-way, which means that we can also send commands to the ESP32 from anywhere in the world via the mobile network. For this purpose, I installed a small blue LED on the microcontroller, which can be any device in the home. To activate this blue LED, we type blue LED on. So / blue LED on. As we see, blue LED now is on. Similarly, to turn off, we type blue LED off. Blue LED is off. So instead of this LED, we can connect any device in the home, for example an electronic lock that we can control remotely. Now we will simulate a flood in the house by filling this container with water. Here is how the system should behave. When the water rises to the sensor, ESP32 should automatically turn on the water pump, while the red LED will light up and the sound alarm will be activated. At the same time, we will receive a message on the smartphone that a flood has occurred. When the pump pumps the water to the required level, it automatically turns off and the user receives a message on the smartphone that the water has been removed and the room is dry. Instead of the blue LED, we can connect the solenoid valve from the main water supply via a relay and thus completely turn off the water supply remotely. In real situation, this sensor and pump would be located below flow level in a specially designed space for that purpose.